And we are back from Easter break, and this is chapter 12, I think, but it's about gases. So even if I'm wrong on the chapter, it's a chapter on gases. There are 4 variables that are needed to describe a gas, and they are pressure, volume, temperature, and the number of moles. And these 4 variables, or these 4 conditions, fully describe any sample of what's known as an ideal gas. We'll discuss an ideal versus a real gas in person. These are abbreviated by P, V, T, and a lowercase m for moles. And you'll find that when we're working with gases, we usually will keep 2 of these variables constant and vary the other 2. So you can plot a nice graph, y versus x, and see if you have a linear relationship or an inverse relationship. The first variable we're going to talk about is pressure. Pressure is defined as force per unit area. So for instance, if you are filling a bicycle tire, you might want to fill the bicycle tire to a pressure of 90 pounds per square inch. Atmospheric pressure, when we're talking in English units, is usually given as 15 pounds per square inch. That means that there's 15 pounds of air pushing down on every 1-inch surface. So if you think about the surface of your head, say if it was, 5 by 8 inches, 40 square inches times 15, 600 pounds of air, that seems like a lot, but then you have air pushing against the side of your face and under your chin and upwards, so that it all kind of cancels out and it doesn't feel quite that heavy. Okay, what atmospheric pressure is, though, is it is the force of a column of air Lumn pressing down on the surface of the earth. So this is a very long, skinny column of air pushing down on the surface. All objects on the planet are subject to atmospheric pressure. I probably don't need to write that down. There are many ways to measure atmospheric pressure, many ways to describe it. The easiest way to measure it is with something called a Torricellian barometer. Okay, and this was done by an Italian chemist called Evangelista Torricelli, whose name I will probably misspell. Everybody always wants to call him Tortellini, but it's not, it's Torricelli. So what Torricelli had in his barometer is very simple. He had an open dish. And he filled this dish with mercury. Now, mercury is very dense. It's 13.5 times denser than water. I can't spell mercury today. And in this dish of mercury, he put a glass tube that was sealed on one end and open at the other end. So this end is sealed. This end is open, and it is sitting in the mercury. And this tube has been evacuated, which means there is no air in the tube. And no, I don't know how he did it. Let's just assume he did it. Okay, so we have no air. We've got nothing in this tube. Now, you've got this dish of mercury. What's pushing down on the mercury in the dish? Normally, I would wait for you guys to figure it out, but you're not here with me. But atmospheric pressure is pushing down on mercury in the dish. So every square inch of mercury has 15 pounds of air pushing down on it. What is pushing down on the mercury that is inside this glass tube, this little tiny bit of mercury here? Nothing. You're right. So if nothing's pushing down here and atmospheric pressure is pushing down on the mercury here, what's going to happen to the mercury in the dish? Right. It's going to go up the tube. And that's exactly what happens. So the mercury gets pushed up the tube to a particular height by the force of the atmosphere pushing down on the mercury in the dish. This height is 760 millimeters of mercury, mmHg, or 760 torr, after Torricelli. And that is considered standard atmospheric pressure. Now, something for you to think about right now, I'm going to ask you about it when I actually see you in class. Figure out how a straw works. A straw in a soda, a straw in a milkshake, a straw in a glass of water. We'll talk about that in a minute. But think about it, because it pertains to this. Okay, we have 760 torr. There are a variety of units for expressing atmospheric pressure. 760 torr obviously equals 760 millimeters of mercury. That equals what we call 1.0 atmosphere, or ATM for short. It is also equal to 101,325 pascals, abbreviated PA, which is the SI unit for pressure, or 101.325 kilopascals. What you need to be able to do with pressure is to solve problems. So for instance, suppose I want to convert 1.75 atmosphere to kilopascals and torr. That was supposed to be atmospheres. Whoops. Convert 1.75 atmospheres into kilopascals and torr. So I would take my given 1.75 atmospheres, and I would look at all these equalities up here, and if I want to get kilopascals, I'm going to have 101.325 kilopascals on the top. I'm going to have 760 torr on the bottom, because 760 torr does equal 101.325 kilopascals. Going to multiply 175 by 101.325, divide by 760, and I get a number that I really can't read. Here it is, 177 kilopascals. To do torr, I'm going to do the exact same thing. To start, 1.75 atmospheres. I want torr, so I know that there are 760 torr in every 1 atmosphere. So I'm going to multiply 1.75 atmospheres by 760 torr, and I end up with units of 1,330 torr. Now, if you want to know why it sounds so funny, quick, my husband's going to show you my mask right before he clips this video really quick and then turn it off. Yeah, hi.